All right, so let's jump right in. Today, we're going to pop the hood on modern AI. We hear all the time about the wild things it can do, but we're going to look at how it really works. And we'll do that by looking at the two big forces that shape it, the pure science part and the nitty-gritty practical engineering side. Look, if you want to understand AI today, you've got to get your head around one word: scale. We are talking about models that are just astronomically bigger, trained on data sets that cover a huge chunk of the entire internet, and they're running on computing power that would have sounded like science fiction just a few years back. This isn't just a small step up, it's a totally different game.
And that brings us to the core question, right? Is this explosion in scale because of some brand new scientific discovery, like finding a new law of physics? Or is it more of an engineering triumph, taking ideas we've had for a while and just executing them on a level nobody thought was possible? Let's dig in. To really get what's happening now, we have to take a quick look back. For a long, long time, the way people tried to build AI was completely different. And honestly, it's the failure of that old way that really paved the road for what we have today. So the first big idea was to basically treat intelligence like a giant, perfect encyclopedia. The thinking went something like this. If we could just write down every single rule about how the world works, what a dog is, why people shave, you name it, and feed it all to a computer, then presto, it'd be smart. This was called the knowledge base approach. And this quote just perfectly captures why that whole idea fell apart. So there was this massive project called Psych, trying to codify all of common sense. You give it a simple story, a guy named Fred is shaving. Well, the AI had a rule that people don't have electrical parts, and it knew an electric razor was electrical, so it logically asked if Fred stopped being a person during the shave. I mean, it's hilarious, but it shows you in a nutshell. You just can't write down enough rules to cover the messy, weird reality of our world. So, that old way was pretty much a dead end. And that failure forced this massive shift in thinking. People started asking, what if instead of telling a computer every single rule, we could build a system that learns the rules all by itself, just by looking at a ton of examples? And that right there is the core idea behind deep learning. Instead of one giant rulebook, it builds up its understanding in layers. It's kind of like how our own brains work. A complex idea like cat isn't just one thing, it's made up of simpler ideas. The system first learns to spot the basic building blocks, like lines, curves, and textures, and then it learns how those blocks fit together to make whiskers, ears, and eventually the whole cat. So here's the best way to picture it. Just think of a deep learning model as a multi-step computer program. The input, say an image, goes into the first layer, which does a really simple task. Its result then becomes the input for the next layer, which does something a bit more complex. And on it goes, with each layer building on the work of the one before it. Let's make that super concrete. Imagine facial recognition. You feed it a picture of a face. The very first layer is just a simple pattern spotter. It's not seeing a face. It's just seeing pixels and learning to find basic stuff like edges and corners. Then, the second layer takes that map of edges and learns to group them into more complex shapes, like an eye or a nose. It's only at that third layer that the system can look at that arrangement of shapes and finally say, aha, that's a face. It's a ladder of complexity, from simple patterns to abstract ideas. Okay, but here's the thing. These ideas, deep learning and neural networks, they've been around for decades. So what was the secret sauce? What were the key ingredients that took these old concepts and supercharged them into world-changing tech like ChatGPT?
It really comes down to these two things. We've already talked about the first one: massive, massive scale. Way more data, way more computing power. But the second ingredient, self-supervision, well, that was the real game changer. It's the clever trick that actually let us use all that scale. So what is self-supervision? This is the genius part. See, in the old days, you needed humans to painstakingly label every piece of data. This is a cat. This is a dog. It was a huge bottleneck. Self-supervision is a way around that. It lets the model create its own learning games from just raw text. It'll take a sentence, hide a word, and then try to guess what word is missing. By doing that billions and billions of times across the whole internet, it starts to learn the deep patterns and structure of language, all without a single human label. Now, within this world of self-supervision, the models are basically playing two different kinds of games. You have auto-regressive models, which are the engines inside tools like ChatGPT. Their game is always the same: predict the very next word. That's what makes them so good at generating new stuff. Then you have masked language models. Their game is to fill in the blanks inside a sentence.
This forces them to get really good at understanding context, which makes them perfect for analysis, like figuring out if a movie review is positive or negative.
So that's the science, the raw potential. But having an incredibly powerful model is one thing. Turning it into a product that people can actually use, that's a whole different challenge. And that is where the engineers come in.
And boy, are they putting it to use. I mean, we're all familiar with the stuff we use every day, right? Writing emails, messing around with a chatbot. But that same core tech is being engineered into all sorts of tools for businesses. Things like automated customer support, deep market research, and systems that can manage a company's entire internal knowledge base. For any company that wants to get in on this, they face this one single massive question. Do we build or do we buy? Do you try to build your own giant foundational model from scratch, which is incredibly expensive and difficult? Or do you just buy access to a model that already exists and build your product on top of that? And let me tell you, this decision is a total minefield. If you decide to build, you could pour millions of dollars into it, only for a big provider to suddenly slash their prices, making your huge investment practically worthless overnight. But if you buy, you're basically at their mercy. Their next big model update could suddenly make your whole product obsolete. It is a huge gamble on a tech landscape that is shifting under your feet every single day. Which brings us right to the frontier of what AI engineering looks like today. The biggest challenges aren't just about writing better algorithms anymore. They're about dealing with the messy human reality of the data these things are built from. Because here's the iron law of AI. Garbage in, garbage out. It's that simple. These models learn from the data we feed them, which is mostly scraped from the internet. And let's be honest, the internet isn't some pristine, curated library of facts. It's, well, it's the internet. And this right here is the raw material that today's AI engineers have to work with. It is an unfiltered dump of the web, with the absolute best of humanity sitting right next to the absolute worst. So a huge part of the job of an AI engineer now isn't just building models, it's trying to clean up and detoxify the very stuff they're made of. And beyond just the quality of the data, there's a massive problem with representation. I mean, look at this table. It compares how common a language is in the real world to how common it is in a major training data set. The numbers are just staggering. A language like Punjabi is over 230 times more common among people than it is in the data. Meanwhile, English is hugely overrepresented. We're not talking about a small bias here. This is a fundamental skew at the very foundation of modern AI. And this shows you the direct consequence of that. It's completely predictable. The model performs best in English because that's the language it's seen the most data for. As you move to languages that are less represented in the data, the performance just drops off a cliff. The imbalance in the data creates a direct imbalance in how well the tool actually works, a huge problem that engineers have to try and solve. So, being an AI engineer today means you are living in the state of organized chaos. You're not just fighting against biased data and technical problems, you're in a frantic race where the rules of the game are changing constantly. The absolute best, smartest tech decision you make today could become the worst possible choice next month when a new model comes out or prices change. And really, that's what it all comes down to. The whole conversation is shifting. For years, the big question was always a scientific one. What's possible? What can AI do? But now, the most important questions are engineering questions. How do we build these things so they're effective and reliable? How do we build them responsibly? And maybe most importantly, how do we engineer them so that their benefits are actually available to everyone, not just the people who speak the languages that happen to dominate the training data? That is the challenge we're facing right now.